Still got a couple more stories here, so let's keep pumping it along. Exoplanets. Kind of wanted to talk about this just in general because I know earlier in the podcast we did talk about the James Webb Space Telescope, specifically teaming up with the Mantis to look at exoplanets. So I thought, why not speak a little bit about exoplanets and our solar system itself and how difficult or how easy is it to actually find one? Well, in fact, even Neptune in our own solar system is hard to see. So it is very, very difficult ways. And obviously, there are different ways to find exoplanets, which I've talked about, the transit method, all of that kind of stuff, you know? All right, so we have how many stars are in the Milky Way? So let's just start off with this. 100,000 million stars. All right, so that really, all right. Uh, there are about 100 billion stars. By measuring that starlight, specifically its color and brightness, astronomers can estimate how many stars our galaxy holds. This is from SciTech Daily. Red, white, and blue stars give off different amounts of light. By measuring that starlight, specifically its color and brightness, astronomers can estimate how many stars our galaxy holds. So that's how they get 100 billion stars. Damn. Um, so, and then, all right, you're just gonna do that. And then it kind of goes on later. Let's look at this right here. Uh, all right, I guess that web page is just gonna be insanely frustrating. All right, moving on. More than half of all sun-like stars in the Milky Way may have a habitable planet. So there is a potentiality that many different solar systems, even ones that are close to us, have the potential for actual life to be there, for planets in the habitable zone, and also for planets themselves to be habitable. On average, each sun-like star in the Milky Way galaxy likely harbors between zero point 0.4 and zero point 0.9 rocky planets in its habitable zone, the just right range of orbital distances where liquid water could be stable on a world's surface. About 7% of the Milky Way's 200 billion stars or so are G dwarf like the sun. So that's a possibility of Earth-like real estate. Depends on where they are. Obviously, around if you're in an orbit that's similar to Mercury, that's not good. And if you're in an orbit that's similar to Jupiter, it's not good. This is the first time that all of the pieces that have been put together to provide a reliable measurement of the number of potentially habitable planets in the galaxy. This is a key term of the Drake equation, something I've talked about before, used to estimate the number of communicable civilizations. We're one step closer on the long road to finding out if we're alone in the cosmos. In the new study, a large team poured over observations by Kepler, which operated from 2009 to 2018, discovered more than 2,800 exoplanets, and Kepler's tally continues to grow. They also examined data on stellar properties from the European Space Agency's Gaia spacecraft, which is precisely mapping 1 billion Milky Way stars. The team used this information to estimate occurrences rates for rocky planets in the habitable zones of sun-like stars that defined rocky planets as worlds with diameters 0.5 to 1.5 times that of Earth, and sun-like stars as those with surface temperatures between 8,180 and 10,880 degrees Fahrenheit. Most of the stars that meet that criterion are G dwarfs and K dwarfs, which are slightly smaller than G dwarfs and about twice as numerous. The habitable zone is a decidedly squishy concept. Whether a planet resides in it depends on the thickness and composition of its atmosphere and the activity level of its host star, among other factors. So Bryson and his team calculated occurrences for rates for both a conservative and optimistic habitable zone, 0.37 to 0.6 planets per star for the former and 0.58 to 0.88 planets per star for the latter. Both of those range have large uncertainties, but the abundantness nevertheless imply that potentially Earth-like worlds are all around us, including in our own solar system's backyard. The research did not consider red dwarfs, also known as M dwarfs, which make up about 3/4 of the Milky Way stellar population. A 2013 study based on Kepler data estimated that about 6% of red dwarf system boast a roughly Earth-like planet in the habitable zone, and one such world is the closest alien world to our system at a distance of approximately 4.2 light years Proxima b, which orbits the red dwarf Proxima Centauri. But the true habitability of planets in red dwarf system is a matter of debate. Because these stars are so dim, their habitable zones live very close in, meaning that planets in this region are likely tidally locked, always showing the same face to their host star, just as the moon does to Earth. Red dwarfs are also much more active than sun-like stars, especially in their youth. So, intense flaring may quickly strip away the atmospheres of worlds that circle in a red dwarf's habitable zone, scientists say. So many options out there, but it's in terms of likelihood of Earth-like planets out there is very, very high, but contextually it's very high, but for us it's very, very low because we've only discovered less than 5,000 exoplanets. And like we said, there's a lot more planets in just our galaxy than a lot more in our galaxy than well, I think it was 200 billion. That's a lot more than 5,000. But I'm not going to watch this video, but I've talked about Anton before. Turns out the solar system is the rarest planetary system out there. Please go watch this video to kind of do more research on this topic.